Good evening and welcome everybody to the 2021 New South Wales Young Tall Poppy of the Awards, the Young Tall Poppy Awards being held online due to our current COVID situation. I'm the General Manager of the Institute, and I begin today by acknowledging the traditional custodians of the land from which we all gather today. Australia always was and always will be Aboriginal and Torres Strait Islander land. The Australian Institute of Policy and Science acknowledges and pays respect to the past, present and future traditional custodians and elders of this nation, and the continuation of cultural, spiritual and educational practices of Aboriginal and Torres Strait Islander peoples. We extend that respect to Aboriginal and Torres Strait Islander peoples joining us for our celebrations this evening. And we acknowledge the many Aboriginal and Torres Strait Islander peoples who have made an important contributions to science and culture and continue to do so. It is my great pleasure to introduce Professor Veronica Power, who is one of the directors of the Institute. Professor Power is the Professor of Bioarchaeology and the Director of the Centre for Ancient Cultural Heritage and Environment at Macquarie University. And she's graciously standing in for Maria Cavalaris, Professor Cavalaris, our co-chair, who is unable to attend this evening. We also have another guest with us, the chair of our selection panel, Professor Pal Thordarson. Pal is the director of NUN New South Wales and the RNA Institute, and he will give us an outline of the selection panel procedures and as we go on through the evening. So I now like to call on to Professor Power to introduce the awards, their history and significance. Thank you, Veronica.
Thank you for your kind introduction, Stephen. It's my pleasure and honour to be with you this evening. I'm joining you tonight from Jarrawanang, or Ashfield, in Sydney's inner west, on the unceded lands of the Wongal people of the Eora Nation. I'd like to start by extending my warmest congratulations to our 2021 New South Wales Young Tall Poppy Science Award winners and wish you all every success in your ongoing research and engagements with the media and the wider community. I'd also like to extend a warm welcome to our audience of family members, colleagues, sponsors and mentors. Thank you all so much for joining our very happy celebrations tonight. Our 2021 New South Wales Young Tall Poppy Science Award winners' achievements are staggering. And I, for one, am deeply personally grateful to them because their endeavours reflect the important life-changing research being carried out across Australia that will ultimately benefit us all. These researchers are shaping the future of healthcare, our natural and social environments, our understanding of our past and of our place in the universe, and all improving our lives in ways that we cannot even begin to imagine. Their passion for communicating their work means many more people across our country and the world will hear about the fantastic science being carried out right here in Australia. Now, as the past 2 years have shown us in many ways, scientific research is vital to Australia's health, well-being and sustainability, our economic growth and our international standing, and as such, it should be nurtured. Tonight's tall poppies are already helping to promote a scientifically literate and engaged society where we can stimulate informed discourse about the future of our communities and inspire a whole new generation of passionate researchers. Here at the Australian Institute of Policy and Science, we have claimed the tall poppy as a metaphor for excellence and endeavour. It symbolises Australia's pride in its outstanding achievers in the sciences. Now, you'll indulge an archaeologist for offering a brief history of our awards. The Tall Poppy campaign was established in 1988 by the Australian Institute of Policy and Science to promote public awareness of Australia's intellectual achievements, particularly those of outstanding early career researchers across the gamut of science, technology, engineering, mathematics, and medical research. We celebrate the diversity of our tall poppies and their research agendas through our program tonight. These Tall Poppy Awards are made state by state, and in 2021 are being presented and celebrated across Australia, either online, as we are doing here tonight, or in person, as local conditions permit. Since commencing, over 850 early career researchers across Australia have been presented with the Young Tall Poppy Award. In New South Wales, there have been over 220 tall poppies, and we have the great pleasure and privilege to admit another stellar group to their number tonight. These prestigious awards uniquely acknowledge the recipients' research achievements alongside their capacity and commitment to communicate science and its significance to the broader community. Indeed, articulating the benefits of scientific research is one of the key objectives of the program, and this is weighted equally with the research achievements when considering our nominees. As we have seen in the past, and we will see with our current cohort, our awardees go on to demonstrate their value as role models by promoting and encouraging an interest and engagement in science within the education and community sectors through our Tall Poppy campaign initiatives. So watch this space for more of that. So, having set our context, it is now my sincere pleasure to introduce Professor Hugh Darren-White, our New South Wales Chief Scientist and Engineer. Welcome, Professor Darren-White, and I'd like to invite you to say a few words about the role and importance of science in our civic lives. Professor Hugh Darren-White.
Well, it's a great pleasure to be here, and I've got to start by congratulating everyone, the award winners. I enjoy this. I do this almost every year. And in fact, what's interesting this year is I recognize rather a large number of people actually on the screen. So hi to everyone who I know. So it's really good to be here. Look, I'm an engineer and a scientist, I'd like to think. I have a role in the state of a number of different things. I might even run through a little bit of what I do, and you'll see how, as Veronica said, outreach and real science and real impact and industry all kind of come together. So a lot of what I do is actually about advising the government. It's about providing, independent evidence-based advice around what to do about brumbies in the Kosciuszko National Park, what to do about coal seam gas, how to manage forests. My other role, one day a week, is I'm also the Commissioner for Natural Resources, which is a very, very contentious area around things like water. So science comes into all of these areas, and in the end, science drives an awful lot of policy making these days in very, very important ways. Second thing I do is actually I support universities. It's key, in fact, to our economic future to have the best researchers, the best people who are capable of, developing skills and new ideas and ideally new industries out of what they do. And so, a government plays an important role trying to attract and really mentor the best people that we're able to have. Actually, one of the recent things is Pally, I see down there, and I have worked together to really try and start building the mRNA industry and research capacity in the state. And I'm pleased to say we've funded Pally, and he's running the New South Wales RNA Alliance at the moment in order to do that. And we hope that we will be able to grow that in terms of attracting industry and everything else as well. The other thing I do is I really try and help to shape industry strategy, future industries. Where are we going in the future? Quantum computing, digital technologies, modern materials, synthetic biology, whole ranges of fantastic things that are out there. And I chair and support a lot of things which I'm sure you'll have heard of. The Medical Devices Fund, which helps to support new medical startup companies, the Physical Sciences Fund, which does the same in the physical area, the new SBIR program, the new Bushfire Technology Fund, a range of different mechanisms for really trying to get you as young researchers to take your ideas and take them out into the real world. And last, but by no means least, is our outreach activities. We play a significant role when it comes to not just tall poppies, but the Premier's Prizes for Science, the science breakfasts, engaging in STEM, really trying to get things in. And actually one of the new initiatives is actually to have biannual events in Parliament House to make sure the politicians also understand that this state is driven by its science and the capability of its young people when they're engaged in science. So it all comes together to really kind of motivate, to drive, to do interesting things, but also to create prosperity and jobs and a future for this country and a future for the planet as well. And I look at the side and we have to take on as scientists now some of the grandest challenges. The pandemic is an example of that, but I'm also actually chair of the Net Zero Board at the moment. What are we going to be doing about carbon in the next decade? And how do we deliver things like that? And we have to be at the front of it. And we have to also make it clear that we need to be at the front of it. It's about evidence, it's about science, it's about changing the world. So congratulations to everyone here. I really wish you the very best. I've known a lot of tall poppies over the years, and they've all gone on to great things. And we have just as much expectation of you as the previous winners have delivered. So congratulations again. Thank you very much.
Thank you so much for your important words and your incredible support and leadership in all you do, Professor Darren White, and for joining us here this evening to celebrate our state's best and brightest emerging scientists. Perhaps a future chief scientist amongst them? Maybe? Let's wait and see. Fingers crossed. It is now my great pleasure to introduce a true hero of today's proceedings, Professor Pali Thordarson, Chair of the New South Wales Tall Poppy Selection Panel. Welcome, Professor Thordarson, and I'd like to invite you to give us a bit of an overview of the selection process this year. It must be one of the toughest jobs in the country. How do you and your team do it, Professor Thordarson?
Yes, thank you, Professor Veronica Power. And first of all, can I just again, congratulate everyone here tonight. I feel like I know you now of the selection process. I'm also one of the proud 220 former New South Wales Tall Poppy awardees. So mine goes back to 2008, and I hope, as you see, it does help you in your career. And you may have picked that up also from the words, very kind words from Hugh Darren White earlier. And I just sort of, before I go into the selection process, just want to point out too, I think that what I've learned from both my role on the selection panel, which I've been on for a few years and I chaired the last 2 years, and it's also from having been awarded one of these prizes in the past, is that I think we saw this particularly in the last 2 years, how important the role of scientists as communicator is, right? And let's not forget the Tall Poppy Award is awarding you both for your excellence in science and also in scientific communication. They're both equally important. So I'll take you through briefly how the process went this year. We had, and also maybe want to start again by thanking all the nominators for all the work they put in for these absolutely fabulous nominations we received. We received 58 nominations. Now, I am very fortunate that we have a good team on the selection panel, I believe, and I want to also read out their names and acknowledge their work. Dr. Mary Louise Conway from the Faculty of Science, Agriculture and Business at the University of New England, Professor Janet Pearce at the Translational Health Research Institute at the Western Sydney University, Professor Alania Amit at the Faculty of Science, University of Technology, Sydney, Professor Melanie Randall at the Faculty of Business and Law at the University of Wollongong, Professor Tracy Westmer at the Faculty of Science and Engineering, Macquarie University, Professor Robert Ryan at the Faculty of Business and Law at the University of Newcastle, and myself, as Veronica said, I come from the School of Chemistry at the NSW. So yeah, so we, 7 of us were tasked with going through these 58 applications, and the way we approach it, as we've done in the last couple of years, we divide up the pile. We take the ones we're not conflicted on, a shorter group, and we do a shortlisting process, which was extremely hard. So typically each one of us would have about 20 people to look at and had to try to pick the 6 best one from that pile. That was so difficult. And then after everyone got looked at by at least 2 judges, and we married these shortlists together. And we were still left then with more than 20 absolutely top candidates. And my heart goes almost out to the ones we couldn't select, because in that final process, we had to make a call, and we're very happy with the final decision. We came to the conclusion that there are 12 people who really deserve the award this year, and you're about to meet them all. So I just want to extend again my gratitude to all my fellows on the selection panel, to all the nominators, everyone who was nominated, whether you were successful or not. And please don't get discouraged if you were not successful. Try again and continue doing your excellent science and communication. And of course, to those of you here tonight, once again, congratulations. And I'll hand back to you, Professor Veronica Power.
Thank you so much for sharing those insights, Professor Thordarson. Wow, 58 nominations and such a competitive field. Indeed, bringing these awards to fruition is no small feat. And I think all assembled here tonight will join me in extending heartfelt thanks to you and our selection committee, as well as our many valued sponsors across the Australian university sector, and of course to our wonderful AIPS staff, including our fearless leader, Professor Maria Cavalaris, and Stephen Burke, Dai Lee, and Julianne Popple. These awards would not be possible without all your support, dedication, and participation. Thank you all so much. Okay, now, without further ado, the moments we have been waiting for, the announcements of our 2021 New South Wales Tall Poppy Award winners. How exciting. I'm going to introduce each of our illustrious awardees and call on them for their first official Tall Poppy Science Communication Challenge to speak for 2 minutes about their research areas. Okay, 2021 New South Wales Tall Poppies, are you ready to go? Let's get started. Let's get started with our first Tall Poppy. It is my pleasure to introduce Dr. Marissa Betts from the University of New England, whose research expertise includes paleontology, animal evolution, and earth science. Congratulations and welcome, Dr. Marissa Betts.
Thank you very much, Professor Power. I'm a paleontologist and geologist. The greatest thing about paleontology, I think, is that it occurs at the crossover of two whole other disciplines, geology and biology. So as a geologist, I come at paleontological questions from a geological angle. I'm excited by the ways that fossils can help us solve big questions about what the Earth was like hundreds of millions of years ago and how they can help us understand geological time. I work on the Cambrian period, which is an interval of time from about 541 to 485 million years ago. The early part of the Cambrian captures one of our planet's most important biological events, the Cambrian explosion. This is not a literal explosion, it's a metaphor for the explosive evolutionary radiation of complex animal life that happened at that time. For billions of years prior to the Cambrian, life was dominated by microbes. But suddenly in the early Cambrian, we see the appearance of an enormous diversity of complex animals. And the evolutionary events of the early Cambrian really set the scene for all subsequent ecological interactions right up until the modern day. So most of the major animal groups living today have their origins 500 million years ago in the early Cambrian. And so do the food webs and symbioses and other kinds of complex animal interactions that we observe today too. But how do we know how old these fossils are? How do we know when these important evolutionary events happened? How do we know how long they persisted for? My work uses Cambrian fossils in addition to geochemical and geological information to create a timeline, to build the geological timescale, to try and put packages of Cambrian rocks in the right order and correlate them around the world.
Wow, fantastic. Thank you so much, Dr. Betts, and congratulations once again on your Tall Poppy Award. What a great way to get started. And let's keep going now with Dr. Tegan Chen from Sydney University, whose research expertise includes 3D printing, biomedical engineering, and pediatrics. Congratulations and welcome, Dr. Tegan Chen.
Thank you so much. I am grateful and honoured to be selected as a New South Wales Young Tall Poppy this year, and I'm so excited to be able to share my work with all of you. I am a biomedical engineer and scientist, and my lab develops and commercializes medical devices for children with nerve, muscle, and bone disorders. Now, it may sound obvious, but children are not just small adults. Children with these conditions need specially made devices, not just because they're smaller than adults, but because they're still growing. However, child-specific devices are not always available, so children and clinicians have to either use nothing, make do, or modify adult devices. We develop solutions for the gaps that exist in the management of children with nerve, muscle, and bone disorders, and we focus on two main areas: bone implants and 3D printed assistive devices. We are making bone implants that either take into account that children continue to grow or use this growth to fix deformities without aggressive surgery. For example, we have designed a wrist fusion plate that is specifically intended to be used for children with cerebral palsy and is now an FDA-approved device. We are also using 3D printing to produce better ankle-foot orthoses, which are an assistive device that supports the lower limb in children who have trouble walking. Current production methods are labor and time intensive, and by using digital technologies like 3D scanning and 3D printing, we hope that we can improve the design and delivery of these devices. Our interdisciplinary team is tackling this challenge from all angles, including using state-of-the-art 3D gait analysis to understand how our 3D printed devices function in the children who wear them, using computational methods to better understand how our devices react to loading, and using co-design methods to design devices that children actually want to wear. And across both these areas, I'm driven to help children with disabilities reach their full potential by designing medical devices and systems that enable them to lead fulfilling and productive lives. So thank you.
Thank you so much, Dr. Cheng, for that wonderful presentation and for sharing your very important work with us this evening. I'm now just so delighted to introduce our next New South Wales Tall Poppy, and that is Dr. Hamish Clark from the University of Wollongong, who is also doing incredibly important work, but some in a very different context. So Dr. Clark's expertise is in bushfire, climate scientists, and environmental risk management. Congratulations and welcome, Dr. Hamish Clark.
Thanks so much, Professor Power. I've got the privilege of living and working on the beautiful land of the Darug and Gundungurra people. And I'd like to start by thanking the Australian Institute of Policy and Science for putting on these awards, raising the public profile of science, celebrating people who can not only do science, but connect with the world outside science is really important. So thank you very much. I also want to thank my wife, Rebecca, and my daughters, Saskia, Freya, and Zadie for supporting me and putting up with me, and thank my parents, rest of my family, my friends, colleagues, and everyone else. Finally, I should say something about my work. I'm extremely grateful that I get to be paid to work on such an important, complicated, and fascinating topic as bushfires. There's a million and one disciplines that you need to figure out what makes them tick, a dizzying range of temporal and spatial scales, and of course us, mysterious, infuriating, inspiring humans in the middle of it all, making some small progress in our knowledge, working with fire managers to try and make a difference to how we live with fire, trying to talk to people about it. It means a lot to me to be able to do these things. Studying the effects of climate change on bushfires is not for the faint-hearted. So I'd just like to end my brief time here by calling for urgent and strong action to reduce our greenhouse gas emissions and work with the rest of humanity to put us on a safer, saner path. Thanks very much.
Thank you so much, Dr. Clark, for not only sharing a little insight into your very important work here in the Australian context, but also for acknowledging all of the people who have come together to make you who you are today. You could say it takes a village, or maybe it takes a field to raise a tall poppy, yeah?
Absolutely.
Absolutely. Thank you so much, Dr. Clark. I'm now delighted and really honoured to introduce our next tall poppy, and that is the one and only Dr. Devika Kamat from Macquarie University. And Dr. Kamat's research expertise is in astronomy, astrophysics, and big data science. Take us away, Dr. Devika Kamat.
Thank you, Professor Power, and I would like to thank the Australian Institute of Policy and Science for choosing me as one of the 2021 New South Wales tall poppies. I'm a stellar astrophysicist. The stars in our night sky and our mysterious universe have baffled me since I was a child. My core research revolves around demystifying what I like to call cosmic alchemy to understand our true place in this glorious universe. You and I, we share a profound connection with the universe. The chemical elements in stars and the gas and dust around them are the very same elements that make up planet Earth, our bodies, and everything we see around us. My research addresses a critical, long-standing question in astrophysics: where do these chemical elements come from? While we know that stars make elements like carbon, oxygen, and nitrogen the essence of life, and even heavier elements like uranium and gold, the physical processes that govern this alchemy is still unknown. It in fact remains unknown for over a century. So my contribution to this research landscape is the discovery of rare stellar fossils, a class of dying stars. These stars preserve a fossil record of their entire life. Using large telescopes all around the world and in space, I try and obtain spectra of these stars. Now, these spectra, they kind of hold unique fingerprints of the chemical elements and also other critical signatures. Using an innovative interplay of the observations with state-of-the-art theoretical models, I try to reconstruct the entire life of a star and figure out how and when were the chemical elements made? How did these elements come into planet Earth? How was life formed? So the research I do tries to reconstruct the processes that happened at the very start of the universe, the event we call Big Bang, and continue to happen today.
Oh, wow. Thank you so much, Dr. Kamat, for your cosmic alchemy and for reminding us all of our connection to our Earth, to our universe, and to time. Such important work. I'm now delighted to introduce Dr. Yoo Heng Lee from Sydney University, who is going to tell us a little bit about their research expertise in chemical biology, synthetic biology, and drug discovery. Congratulations and welcome, Dr. Yoo Heng Lee.
Thanks so much, Professor Power, and thanks to the AIPS as well. So my team at the University of Sydney does research in synthetic chemistry and synthetic biology, and so I think I need to unpack what exactly that means, right? We're in the business of designing and building molecules, right? It so happens that the entire world around you is made from that, right? The screen you're literally watching me on, right? The medicines you take when you're ill, or the fuel that powers your car, that's all molecules that somebody had to design or make, right? So I think of myself as like a molecular architect. And our team is solving some of the world's biggest challenges, so like climate change, treating cancer. And we do that by designing molecules that are inspired by the world around us. Here's an analogy for how that works, right? So maybe you have a challenge and it's to build the perfect home office to maximize your productivity, and you're doing some renovation. So you put your architect, or builder, or engineer's hat on, you go and study some other office designs. You pick the bits you like the best, and this works together. And what are they made from? You create a plan, you buy the materials and tools, and you build it. We do the same thing at the molecular level. So we study how, for example, plants and algae use molecules to capture carbon. Then we take those designs and we adapt them to create our own molecules that can capture carbon even more efficiently. Likewise, we also study the molecules in cancers that are responsible for making them cancerous, and use those very molecules against them to disrupt that cancer. So it's about understanding how molecules work in nature, and then using that knowledge to design solutions for our future. But beyond carbon capture, beyond cancer therapy, I think the most exciting thing we do is fundamental research. We're learning the ground rules of how molecules are built. And it's kind of like the alphabet, right? If you understand the rules, you can build anything. So who knows, right? When the next surprise global event comes along, It's going to be the chemists and biologists like us who will be ready with the capability to tackle it by understanding how it works at the molecular level.
Thank you so much, Dr. Lau. Your work is so important, really addressing the big questions that are facing our society today, but also how wonderful and how inspiring that you are making this so accessible, as you just demonstrated now, for all of us to get on board and to see what we can do to help solve some of these really significant problems. Thank you so much, Dr. Lau. I'm now delighted and honoured to introduce our next tall poppy. And we have Associate Professor Hannah Power from the University of Newcastle, whose important research expertise is on the geoscience of coastal hazards and processes, tsunamis, and coral reefs. Congratulations and welcome, Associate Professor Hannah Power.
Thank you very much, Professor Power, and thank you to the AIPS and to my nominator for this award. As Professor Power said, I work on our coasts and our oceans, and I'm lucky enough to be able to call Australia's beautiful coastal environments my natural laboratory. I work on our beaches, our estuaries, and offshore. And I work on the processes that drive change in these environments. So how the waves move sand around, how the tides change the water levels in our estuaries, and what kind of hazards we get when we get tsunami. Do we get storms building extreme water levels? And I look at how these processes potentially impact our communities. So for example, in our estuaries, I look at how tides in estuaries differ in different estuary environments. So how does one estuary differ from another? And how will that change with climate change? Because we see that it's changing, and how will it change with sea level rise? I also look at what happens on our sandy beaches, and I look at the hazards that we experience there and how they're driven by the waves that arrive on the coast every day. So I look at things like designing better models to predict how high up beaches waves will impact and whether or not that will have an impact on dunes, on things like beach erosion, and on our infrastructure. And I also look at our extreme hazards along the coast, like things like tsunami. So I look at things like tsunami generated by underwater earthquakes, and also tsunami that are generated by underwater landslides, which is something that not everyone is aware of. And they're a potential risk to Australia. We're lucky that we don't have a huge risk from tsunami in Australia, so it's something that we should be alert about, but not alarmed. And I also look at how our environments evolve over time. We recently did a large study on the Lower Murray River, looking at how that environment has evolved over the last 20,000 years and how it's developed into the environment we see today, and how those things have the potential to change with climate change. Thank you.
Thank you so much, Associate Professor Power, for sharing those insights into your important research in some of Australia's most ancient, most dynamic, and most iconic landscapes, our coasts. Thank you so much, Associate Professor Power. I'm now delighted to introduce our next New South Wales 2021 Tall Poppy. We have Dr. Miken Euland with us from the University of Technology, Sydney. And Dr. Euland's very interesting research is on forensic and analytical chemistry, disaster response, and search and rescue. I can't wait to hear more about this. Congratulations and welcome, Dr. Miken Euland.
Thank you so much, Professor Power. So I work on finding missing persons in events like mass disasters, which unfortunately are increasing globally. A lot has to do with climate change for that. And these disasters, they can be earthquakes, we can have explosions, we can have floods and fires, which we are obviously in Australia a lot more familiar with. And at the moment, the way we find victims in these disasters is actually to manually search, which can be really dangerous, not only for the search and rescue personnel, but also for surviving victims that may still be trapped under there. Searches can also be done using imaging techniques, but these may not always work in all scenarios. So I'm working on something a little bit different, and some find a little bit strange. I'm actually using the smell of these victims to find them. So much like scent detection dogs do when they're searching for people. And these dogs can be really amazing tools in mass disasters. But unfortunately, they can get things wrong sometimes. They're really expensive to train and upkeep. They don't work for that long hours until they get bored or too full to keep going. And most importantly, we can't really put them in all kinds of dangerous environments, which a lot of disasters are. So instead of using the dogs, I'm actually chemically smelling humans, which again, sounds a bit on the odd side. It's not me sniffing around in the disaster scenario. Instead, I'm developing an electronic nose to do this work. And this electronic nose will be fitted to drones that can be remotely operated to do these searches. And these tools, they're a lot more cost efficient. They can operate for longer. And most importantly, we can put them in any kind of scenario without there being any danger to human or animal life. So I've been developing and testing these electronic noses on large simulated mass disasters. And I do this at a very specialist facility where we're able to use donated whole human bodies for this research. And what that means is that we'll be able to say with full confidence that what the electronic nose is picking up is actually human, and we know that it's going to work in these very complex situations. And this electronic nose technology will allow us to find people faster and ultimately save lives. And also, which is very important, we'll be able to give answers to anxious family members that are waiting of deceased individuals as well. So it's equally as important to find them. And overall, this research will really revolutionize the way we handle mass disasters. Thank you.
Thank you so much, Dr. Euland. Your research and forensics is a field that we all pray that we'll never need, but when we need you, we are so glad that you are there. So thank you for your incredible research, and really interesting to see the crossover between some of the tall poppies tonight. Your research stands alongside our colleagues who are working in fire and in flood. And wonderful to see that coalescence amongst you all this evening. Thank you so much, Dr. Euland. I'm now delighted to introduce Dr. Oraziovittorio from the Children's Cancer Institute at the University of New South Wales. And Dr. Vittorio works on various aspects of brain cancer, including high-grade gliomas, neuroblastoma, cancer metabolism, and PET imaging. Congratulations and welcome, Dr. Oraziovittorio.
Thank you, Professor Power. It's a very great pleasure for me to be here, and I'm really grateful for the Tall Poppy Award. My research focuses on understanding the biology of those aggressive childhood cancer. In particular, neuroblastoma and high-grade glioma. They're very aggressive, and unfortunately, they kill too many kids. So in Australia, brain cancer kills more children than any other disease. We today have the technology to better understand the biology, what makes those cancers so aggressive, and understand how we can target and kill those tumors. So with my team, we discovered that those tumors are dependent on metals like copper. So copper is very important for their growth, for allowing them to spread and also to avoid the immune system. So we discovered that actually they use copper as a sort of shield to disappear from the immune system. So the immune system cannot see them and cannot attack them. So the aim of my research is try to better understand how we can remove copper from the tumor, how we can use new drugs and develop a new technique to remove copper from the tumor and make the tumor visible for the immune system. In this way, we hope that we can develop strategies to target and kill specifically the bad tumor cells in the brain and improve the quality of life of the children with cancer, but also to improve the survival. Nowadays, we can do that, and we will do that. It's only a question of time. Thank you.
Thank you so much, Dr. Vittorio. Again, such critically important work, and we can all only wish you speed and success in all your endeavours. Thank you so much, Dr. Vittorio. I now have the great pleasure to introduce Dr. Georgia Ward-Fear from Macquarie University, whose research expertise is evolutionary biology, animal behaviour and invasion ecology. And it's possible that Dr. Georgia Ward-Fear is joining us from a rather exotic destination tonight. She might be able to tell us a little bit more about that. Congratulations and welcome, Dr. Georgia Ward-Fear.
Thanks, Professor Power, and thanks, AIPS. Yes, I am joining you from the field in Northern Australia. I was one of those kids that knew what I wanted to do at the age of 10, and now I'm doing it. I'm a wildlife biologist. My work's taken me all around Australia, and I focus on evolution, ecology, and animal behaviour. Most of the time, I feel like I'm unravelling the mysteries of nature, which is pretty cool. But the most rewarding part of that is when I can apply that research to conservation challenges such as invasive species, because then I'm protecting wild animals in wild places, which is my real passion and motivation. Currently, I am decreasing the impact of toxic cane toads on native predators across Northern Australia. But I'm doing that in a really interesting way. I'm actually teaching the native animals that cane toads are bad by going ahead of the invasion, exposing the native predators to small doses of cane toad toxin that makes them sick but doesn't kill them. Then when the invasion comes through, those animals remember that experience, they avoid cane toads and they survive. So it sounds simple. It's not as simple as it sounds though, but it's really innovative, and the project has been really successful, which is always good in science. But importantly, it's changing the way that we think about solutions for invasive species, which are huge problems globally. And the results of our research are already rippling out through the world. The other really exciting part of my research stems from the collaborations that I have with Indigenous traditional owners. I work with many Indigenous cultural groups across Northern Australia, and they have been absolutely pivotal to the success of the research and of the wider conservation strategy. So working together has many benefits. It's not just professional, cultural, social. It actually leads to better scientific outcomes. And so we're really showing the world about the synergies that can be created between traditional ecological knowledge and Western science. And we're pumping that message out loud and proud through any means that we can. And so that part of our research is gaining a lot of attention. So we're changing paradigms, not just in the research ethics and protocols, but also diversity and inclusion. And in that way, we're aiding the scientific community, but also society as a whole.
Fantastic. Thank you so much, Dr. Ward-Fear. Your work is so important, not only for protecting and conserving our precious native environments, but also, of course, demonstrating just how important it is to bring science and culture together. We always achieve so much more when we're bringing all of these incredible experts and local knowledge together. Congratulations for your enterprising approach, and wishing you every success, and stay safe up there, yeah? So thank you so much, Dr. Ward-Fear. And now I have the extraordinary pleasure to announce our 2021 New South Wales Young Tall Poppy of the Year. This is very exciting, the crescendo of our time together tonight. So our 2021 New South Wales Young Tall Poppy of the Year also has expertise in conservation science, biodiversity, and environmental monitoring. I am absolutely delighted to introduce Dr. Aisha Tulik from Sydney University, our 2021 New South Wales Young Tall Poppy of the Year. Congratulations and welcome, Dr. Aisha Tulik. Take it away.
Thanks so much, Professor Power. I'm just so thankful to the Australian Institute of Policy and Science, and really honoured to be awarded this, surrounded by such an amazing group of talented researchers. I'd like to thank my nominator, Professor Glenda Wardle, and my mentor, Professor Hugh Possingham, my family, and just everyone I have the privilege of working with. I really am lucky to work with amazing people, and they're all tall poppies to me. So I just really do love helping people who aren't researchers to learn more about science, to better understand people's impacts on nature, and, to contribute to lessening these impacts. Unfortunately, you may or may not know that Australia is becoming renowned around the world for its just abysmal record of animal and plant extinctions and really shocking rates of land clearing, instead of being celebrated for its unique natural places and wildlife. Unfortunately, there just isn't enough money and people power to recover every species in every part of the continent, as much as we would really love to. So my goal is to work with the people and the organisations that want to help recover wildlife, whether it's on farms or in national parks, to help them make the best decisions for nature as well as for them. That means thinking not only about the native plants and animals that we're trying to recover, but also about the outcomes of the management actions for people, the costs, and also the challenges that we might have working on the land to recover our loss to nature. So I'm really proud of having been part of some really great science teams like the Threatened Species Index for Australia. What we try to do is we build decision support tools that can have a real difference to what we know about the state of our environment and how we make decisions about managing the land. The National Threatened Species Index, for example, is now available around the world for anyone to log in and have a look at, how is Australia's threatened wildlife faring, and how have we been doing at managing these wildlife and recovering them? So it's been a really great achievement, to have that online for everyone to log into. I guess I just want to finish by saying I think that scientists miss really great opportunities when we focus just on publishing in academic journals. And I want to encourage scientists everywhere to create chances for the public to engage more with their stories and discoveries, whether it's through activities, art, writing, media, citizen science, you name it. I think we have amazing stories to tell, and these stories have the power to change the world. So thank you.
Thank you so much, Dr. Tulik, for offering that final tall poppy presentation for the night on another incredible scientist who is working in conservation of our precious, unique, ancient and irreplaceable country. I admire and am so inspired by your work, and I just want to extend heartfelt, most sincere congratulations to you once again for being named as the 2021 New South Wales Young Tall Poppy of the Year, an absolutely outstanding achievement. And I loved your comments as well about community engagement and just how important it is to get everybody engaged. We'll all achieve so much more when we're all working together as a community. So thank you so much, Dr. Tulik, and congratulations again.
Thank you.
And congratulations to all of our awardees tonight. I'm sure that our audience will agree that our future in New South Wales feels a lot brighter tonight, knowing we have such exceptional scientists making such significant impacts already in the early years of their careers. We will keenly watch and support you all over the years to come. But for tonight, we celebrate you and all you have done, all the hard work, all the dedication, and the enormous personal and professional investments that you bring and you have brought to achieve this recognition tonight. Congratulations. We recognize and celebrate you all. Super congratulations. Now, I think that's me done for the moment. It is time for me to pass back to Stephen Burke to bring tonight's proceeding to a close. Thank you all, and thank you, Stephen.
Thank you very much, Professor Power, and everyone for attending. It's my very great sorrow to say, unfortunately, I can't ask you all to join us for a drink and canapes, which we would do. However, that's COVID. Great to see you all. Do enjoy your time. We will be in touch about doing other work with us as your tall poppies. But thank you again to Professor Power for stepping in and chairing our session. Beautiful to hear the way you summed up people's work and the great passion that they all exhibit for their science. Thank you to Professor Hugh Darren for coming along and bringing us up to speed with what's going on, and I guess confirming the importance of science as a key strategic option for this state and our community. To Professor Pally Thordarson, has the unenviable job of refereeing the selection panel to come up with these decisions. It's not easy, and Pal did mention the support of the selection panel. These people give up their time and expertise. All in all, though, it's done to support the role of your careers and the advancements of science in our community. So thank you once again, everybody. Keep safe, and we will be in touch. That's all for the night. Good evening.